As amazing as AI models are, they do have some weaknesses. Sometimes they hallucinate, and you can't just tell them not to because they don't always know that they're hallucinating. If you get a good answer to a question one time, you can't guarantee that you're going to get a good answer to that same question the very next time. And if you ask about something that happened in the last few weeks or months or even a year, there's a good chance the model won't know anything about it. The reason for this is that models take a while to get trained, and it can take months to get them up to the level that they're at. And that means that last bit of knowledge they have is from at least several months ago. Unless you get a fine-tune, which might be a little bit more recent, but then again, fine-tunes don't really add a lot of recent facts. And when you do get them to learn new facts, they tend to get slower. So how can you get it to know about more recent events? There are a few approaches you can take, and in this session of the free Ollama course, we're going to take a look at one of them. Welcome back to the Ollama course. This is a free course available here on this YouTube channel that will teach you everything you need to know about how to use Ollama to run artificial intelligence models locally on your laptop, on your computer, or even on an instance way up there in the cloud. So far in this course, we've mostly covered how to use the basic functionality of Ollama and how to find models, as well as the fact that size doesn't always matter. And now we move to one of the most common techniques for getting more recent info into your model. It can also be useful for getting it to know about special techniques and processes only you or your company knows about. It's called RAG, and that stands for Retrieval Augmented Generation. So the model generates an answer, and it's augmented with what it can retrieve from a collection of documents. But there are a few steps you need to do to prepare for the prompt. First, consider the type of documents that you're going to be working with. The best types are documents you can get the pure text from without any obfuscation. PDF was created to make it easier to print a document on a printer without having to worry about fonts downloaded to your printer. Yeah, a long time ago, we had to buy printers with fonts loaded on them. And you could load more as well. And the only fonts it could print were the ones the printer actually knew about. PDF was pretty revolutionary, making it easier to get a printed page that looks exactly the same as what's on the screen. Getting readable, sensible text out of it for a computer has never been the goal of PDF, and sometimes the format is used to ensure that that cannot happen. So if you're working with PDF, then take a few extra minutes to get access to the source document. In 99% of the cases that I've seen, the source text is always available, though it sometimes requires an email to the author or publisher. You probably don't want to go through the hassle, but getting clean text from the document is often even more of a hassle. But if you are in that 1%, and you probably aren't, but if you are, there are some tools that do a fair job at attempting to get clean text out of the PDF. Tools like PyPDF or PyMuPDF and others can do a decent job on some docs, but fail to get good clean text on many others until you tweak them for each document. In fact, PyMuPDF's docs say that it's the PDF author's responsibility to make it easier for PyMuPDF to work, which seems like a bit of a cop-out. The reason all of this is important is that if you get text that is jumbled up, you aren't going to get great results from your RAG system. Now, you might wonder how so many tools out there get it right with various tools. Well, sometimes they get lucky, and sometimes they don't, because PDF is hard. But let's assume that you've loaded up a doc and gotten the text out of it. Now we need to store that content somewhere. But we can't store it as one contiguous stream of text. There are a few reasons for this. The first is context size. Even if the document fits in the context, having a conversation with the document may fill the context later on. And if most of the document doesn't help answer the question, why even include it? Second, sending too much data to the model regardless of the context size can confuse it. Not everyone is a great writer, and opposing viewpoints in one doc or a collection of docs can often have ill effects on the final output. Sometimes it helps, usually it doesn't. So we want to split up or chunk the text. This is an area that has a lot of options and no one best solution. Some like to split the text by pure character count. others by tokens or maybe words, or even paragraphs or sections of the document. Then you may want to have overlap that each chunk shares. So now let's say we have our chunks of text. We need a way to find the most relevant chunks of text depending on our prompt. This is where embeddings come in. Embeddings are a numerical representation of our text. We pass the chunk of text through a special embedding model, and that figures out the semantic meaning of the text, which is represented by a vector in a space with many dimensions. Exactly how many dimensions depends on the model. All text that is embedded will end up being a vector of a certain length. Different embedding models produce vectors of different lengths. So if you change the embedding model later on, you need to re-embed all the chunks in your system. The magic of embedding is that if the vectors are the same length, then it's mathematically very easy to compare them and find the chunks closest to the meaning of the original prompt. There are a few algorithms used for this comparison, and depending on how you store the chunks, you may have more or fewer choices. So how do you store the chunks? Well, you could store them in a JSON file on your system, or as separate files. But as soon as you get into the thousands of chunks, you run into scalability issues. It's going to be far more efficient to store them in what's called a vector database. There are a lot of options here. Last I saw, there were 50 plus, with some of the most popular being Chroma, or Pinecone, or Milvus, or even add-ons to your favorite relational databases like Postgres. So at this point, you have a vector store with chunks stored in it. For each chunk, you have the embedding stored, but you also need to store the source text. The reason for this is that we need to use the embedding to find the most similar text, and then we need to provide the raw text to the model in the prompt. Now, it is possible to recreate the text from the embedding most of the time, but it's just more efficient if you store the text with the chunk. So now you need to build the prompt. You probably started with a question like, explain something from this quarterly financial report. You created an embedding of that question and did a query to the database looking for the most similar chunks in the database. It can potentially return a lot of results, and they all have a ranking of how close they are. So you choose the top 5 or 10 results and grab the text. Then add something like, use the following information to answer the question, and then include the text from each chunk. And then pass that whole string to the model in your prompt. The rest is the same as every other interaction with a model. Models just understand text in the input prompt, so the goal of RAG is to find the relevant chunks of text and include them in the prompt. This essentially makes the model know about things it didn't really know about before. So in this video, what we saw is RAG is a way to get relevant text to the prompt so that a model can know about specific information on a topic. It gets that text by looking in a vector database for chunks of text, which are fragments of the source documents that are semantically similar to the question in the prompt. Those chunks are stored in the database as raw text and an embedding, which is a numerical vector generated by a special embedding model. In upcoming videos, we'll look at the components of RAG in a bit more detail and actually start using some of them. We'll also build a complete RAG system, as well as try out some of the existing tools that have RAG built in. There are some great options out there, including OpenWebUI, Misty, and Page Assist. But this video is long enough just talking about the high-level concepts. Thanks so much for watching this video in the course, and I hope you have a great time making AI part of your life using Ollama. Goodbye.